Okay, so as well as being able to answer questions like that, we also want to have some summary values. So we've got here, and we use this word average all over the place. And statisticians don't like the word average, but I don't really mind. It's a really blanket term. It's not precise. So if somebody asks you for the average, it can actually mean several different things. If you're talking about houses, it can mean the median. If you're talking about most things, it means the mean. And in this, it means the expected value. So when we're talking about a probability distribution, the average is called the expected value. So we say the expected value of x equals x times the probability of x. And because of Module 1, you now know how to use these little sigma signs. And so that means that we're going to go x, which was 0. Yep. So we've got 0 times 0.16 plus 1 times 0.2. Is that working? Oh, yeah. Plus 2 times 0.32, and so on. And in fact, if you do it in Excel, you can use a thing called sum product, which is really handy. You just go sum product, and then you highlight that, comma, and then you highlight that, and it will give you your expected value. Okay, so all that means is sort of like the average. It's not the most likely one necessarily, but if you're trying to work out on average how many do we sell, so over, say, 50 weeks or whatever, that's what you use as the expected value. Now we also want to know how spread out things are, and we use a thing called a standard deviation, but I don't believe in people knowing how to calculate a standard deviation. And this is one of the ways that this course is a little different from most stats course, because I think it's like driving a car. I mean, who cares how it works? It does. Or watching television or any of those things, is that you don't need to know how to calculate a standard deviation. What you do need to know is what does it mean? And basically what it means is how spread out the distribution is. So we're not calculating it. So you can think of it as roughly as the average distance of a value from the mean. So the standard deviation for this one is 1.47. So what it's saying is that most of the values are within 1.5 of the mean, and the mean or the expected value was 2. So most of them are going to be 1, 2 or 3, or getting up and towards 0 and 4, and that makes sense. But if we'd had numbers out from up to 10, we would have had a higher mean probably, or expected value, and our standard deviation would have been bigger as well.